Hello, this is the fifth video in the series of number systems. We're going to be discussing in this video subtraction in different number systems. So the first example is in decimal. So we're going to be doing subtraction in decimal. We have two numbers there. We have 547 minus 269. Now in grade school, you were taught to do this by column. So let's do that. Now, 7 minus 9 first. 7 needs to borrow from 4, right? So 4 becomes 3. Now, the one that 7 actually borrows from 4 is equivalent to a 10 because this is the decimal number system. So we add 10 to 7, making it now 17. Then we subtract 9 from 17, getting an 8. Now for the next column, we have 3 minus 6. Now we can't just subtract 6 from that, so 3 needs to borrow from 5. 5 becomes 4. Now the one that 3 borrowed from 5 is actually equivalent to 10. So we add 10 to 3, making it 13. Now we proceed. 13 minus 6 is 7. And for the last column, we have 4 minus 2, giving us 2. And there you go. The answer is 278. Now, the next slide is an example in octal numbers. So we have 723 in base 8 minus 265 in base 8. So starting with 3 minus 5. So again, 3 needs to borrow from 2. So 2 becomes 1. Now, the one that 3 borrowed from 2 is equivalent to 8 because this is octal. So we need to add 8 to 3, getting 11. Then we subtract 5 from 11, giving us 6. For the next column, we have 1 minus 6. So 1 needs to borrow from 7. So 7 gets to be 6 now. Then the one that 1 borrowed from 7 is equivalent to 8. So we need to add 8 to 1, making that 9. Then we proceed to subtraction. 9 minus 6, you get 3. And for the last column, you get 6 minus 2, you get 4. Then you affix the base, so you have 436 in base 8. Now the next example is in hexadecimal. So you have 8A5 in hex and subtracted by 2B9 in hex. So to start with, we have 5 minus 9. Obviously, 5 needs to borrow from A. So we get 1 from A becomes 9. Now, what 5 borrowed from A is 16. So we need to add 16 to 5, making it 21. Then we subtract 9 from 21, which is 12. Then we proceed to the next column. So we have 9 minus B. Again, B is greater than 9, so 9 needs to borrow from 8. So 8 becomes 7. Now, 9 borrowed 1 from 8, so that one is equivalent to 16, and we need to add that to 9. So 9 becomes now 25. So we need to subtract B, or 11, from 25, giving us 14. For the last column, we have 7 minus 2, and the answer there is 5. Now, the answer is not 5, 1, 4, 1, 2, but rather we just need to write down the equivalent hexadecimal numbers, which are 5, E, C, and affix the base. So your answer is 5EC in base 16. Next, let's take a look at binary numbers. Now, before that, I'd like to show you the operations you need to remember in binary numbers. So, you have 0 minus 0. The answer is always going to be a 0. 1 minus 0 is 1. 1 minus 1 is 0. But when you subtract 1 from 0, the answer would be 1 with a borrow of 1. Okay? Now, let's go to the example. Now we have here 10110 in base 2 minus 1011 in base 2. I have a slightly different approach to this. We will be discussing the same process after this slide, but for now, please follow what I'm going to be doing. So we start off with the first column. So 0 minus 1. So 0 needs to get a borrow from 1. So the 1 there becomes a 0, and 0 becomes 1 0. Recall that 1 0 in binary is equivalent to 2 in decimal. So it actually borrowed a 2 from 1, and I'm writing it down as 1 0 or binary. So 1 0 minus 1 or 2 minus 1 is 1. For the next column, the second column, we have 0 there. We're going to be subtracting 1 from that. So again, it needs to borrow from 1 again. That 1 becomes now 0, and the 0 in the second column now becomes a what? A 1 0 or 2. Now 1 0 minus 1 or 2 minus 1 is 1. Now for the third column, you have 0 minus 0, so that's just going to give you a 0. Now for the next column, 0 needs to borrow 1 again from there, and that 1 becomes 0. The 0 here becomes, again, 1 0 or 2. The 1 0 minus 1 or 2 minus 1 is equivalent to 1. That's your answer with 1 0 1 1 and fix the base of 2. Okay, now using the same example, we will be doing this the same way we did the subtraction in the other slides. So starting with 0 minus 1. Now 0 needs to get to borrow from 1, right? Now 1 becomes 0. But what we're actually borrowing is a 2. So let me write that down as a decimal. Now 2 minus 1 is 1. Now for the second column, we have 0 needs to borrow from 1 again, making that one 0. And the 0 in the second column is now 2 because we add 2 to that from borrowing from the third column. Now 2 minus 1 is 1. Now for the third column, we have 0 minus 0. You're still going to get 0. And for the fourth column, well, 0 needs to borrow from 1, making that one 0 now. And 0, we're going to be adding 2 to that, so you get 2. Then 2 minus 1 is 1, and then affix the base to that, so you get 1 0 1 1 in base 2. Now the only difference between this slide and the previous one is that in the previous one I made use of purely binary numbers, and in this slide, as you can see, I used the decimal numbers. Now it really just depends on your preference, whichever makes it easier for you. Now when it comes to other bases, you just need to follow the same process and you're still going to be getting the correct answers. So that's it. Thank you for watching.